Hello, everyone. Welcome to CFD College. I'm Ashkan, and we are going to continue our course on post processing in CFD Post in this video. I hope you enjoyed our previous videos on not only CFD Post but also tech plots, design modeler, ANSYS machine, and other, and especially ANSYS Fluent, other videos that we have posted so far. And in this tutorial, we will continue our course on CFD Post. So far, we have done uh, 10, yes, of course, these 10 parts. And now we are at the 11th step, animation. So in this video, I'm going to show you how you can create contour animations uh, in CFD Post. Uh, you know, uh, Animation using animation in transient simulation is a good way to show your results, show the flow field to the audience, and using animations you can uh, see the flow evolution during time. So you can use it for your understanding, and also you can use it to show perfect uh, clips, short clips, of course, from your CFD simulations. So before starting the video, this session, please subscribe the channel if you haven't done this yet. This way you don't miss our future videos. If you find these videos useful, please share these with your friends and give us a thumbs up button. It helps us, and it's the only support uh, I ask you to provide me with, and this is the only this can encourage us to produce uh, further videos on CFD. So let's jump to the workbench. This is, as you know, ANSYS workbench. Here I have a Fluent block. I've solved the flow over a cylinder, over a circular cylinder at Reynolds number of 100. And now the simulation has finished, and I'm ready to create some animations in CFD Post. Uh, I should tell you this. If you are working in Workbench, you don't need to do anything to create, uh, you know, uh, animations after uh, the simulation is finished. Uh, I think you know that you can create animations in Fluent, and to create animation in ANSYS Fluent, you have to define the animation before you start the simulation. Before you start the simulation, here under the calculation activities tab, you can see solution animations. It's not. Uh, I'm not going to talk about this in this video. We have another video regarding this matter. But if you want to um, create some animations in CFD Post after after the calculation is finished, you have to specify the number or autosave number for your calculations, for your simulation. It depends on the time step size, on the number of time steps that you have, and the just this. For me, I've simulated the flow over a cylinder for 300 time steps. As you can see here, this is the 300 data, and with the time step of 0.01 second. So here I specified 10 uh, for autosave the data file. Means that it means that I have the data file each 0.1 second in my simulation. So you have to decide on this yourself. Depending on your simulation, the time step size, and the number of time steps you have, and it's enough for you if you are working in Workbench. If you would like to, create animation in standalone CFD Post, or let's say if you are working with standalone Fluent, you have to create some automatic export. To do that, you should click on this, create this icon, and then solution data export. Uh, Change the file type to CDAT for CFD Post and Insight, and select the quantities that you want, and of course the export data frequency. Here, as you can see, it's 10 each every 10 time step. This CDAT file will be saved, and using these CDAT files you can create or let's say you can import transient data in CFD Post, in standalone CFD Post. So if you are working in Workbench, you don't need to create this automatic export. But if you are working with ANSYS Fluent in standalone mode, you have to create that automatic export. Don't forget that. This way, after the simulation, you can go to no, you can go to the directory that you chose before, when you wanted to run the standalone Fluent. Here, since I'm working in Workbench, this is the directory, and in that case, you will have these files, these CDAT files, and you should import the last one into the standalone CFD Post, and after that you are able to see the results in time. So here I'm working in Workbench, so I can simply go to results. There is no need to create any automatic export. Uh, this is the domain 2D simulation, flow over a cylinder. Here is the inlet, the outlet, the sides, and this is the cylinder. If you click on this time step selector, you can see here all the data from the uh, start time up to 3 seconds, the 300th time step are here, and you can choose each of them as you need. So let me select symmetry 1. If you don't know how you should create, how you can create contour, you have to watch our previous videos. But if you know what I'm doing. Let's see velocity contour. This is the velocity contour on symmetry 1. Uh, let's go to default legend view 1 and change it to modify it to variable only. So velocity This is the unit, and let me modify the format. So fixed, which is a numerical format, and with one precision. Okay, this is the uh, velocity contour at 3 seconds. So if you double click on each of them, you can see the flow field at the desired time. As you can see the evolution of vortex street, von Karman vortex. If you want to see a better representation, you can use Z vorticity contour, but you may need some expressions, and then you should define it as a variable, and then you can create its contour. So in this video, I'm going to continue with velocity contour. So first, let's remove this ruler from the viewer. Okay, deselect the ruler. Now it's gone. And I think it's okay to generate a to generate an animation. You should first go to the first data and then click on this icon animation. Here you have different choices: sweep animation, GPU accelerated animation, keyframe animation, and timestamp animation. This is the one that I'm going to show you in this tutorial. Uh, we may, I may record some video about sweep animation and keyframe animation in near future, but now uh, we should work on timestep animation because this is a transient simulation. In sweep animation or keyframe animation, you can use them in steady state simulations, but for transient simulation, this is the option, timestep animation, because we want to see the velocity field over time. Here you can see the current time step. You can change it here, and controlled by option. We have two options: time step or time. If you select this, you can specify the range for time for animation, the range of time step. For example, now I will have an animation from the time step number 10 up to 300. You can change it if you want. For example, you can reduce this end time step number or increase this one. And mm, okay, it's not so important. Here, if you see, you can save this animation if you select this option. This is the repeat option. It's now on 1. It means that the animation starts from the beginning and goes to the end. If you increase it, it will repeat again and again and again. It depends on the number. You have infinite option, repeat forever, which in this by this option you cannot save it because it doesn't have any meaning. So only one repeat, or sorry, only one round from beginning to the end is enough for me. If you click on the play button, you can see the animation on the screen. You can see it. If you wanna have a smooth animation, you should decrease the autosave frequency. In this simulation, it's 10, I think. Yes, it's 10, as you know. So if you want to have smoother animation, you should decrease that frequency before you start the calculation in ANSYS Fluent. Or you may use some AI to increase the number of frames. Now, let me. Okay, now we are watching the first time step. Select the save movie option. You can modify the format. I think MPEG-4 is the best one. And then the user files. Okay, I think the directory is good. And if you click on the option, you can change or modify some of the settings. This one is not it's not for this kind of animation. Uh, the symbols are used in streamline animations, so it doesn't matter uh, to select, check, or deselect this option for now. If you go to advanced, you can modify the frame rate 24 frames per second. If you increase it, you may have 60 frames per second. Remember that I only have 30 frames in my, considering that I use the autosave frequency of 10 and I ran the simulation for only 300 time steps. So I only have I only have 30 frames. So let's have 24 for the frame rate, and you can modify the quality. The highest is the better. You know that. Although the size of the animation can be a bit high. Now, if you click on play, you can see the animation on the screen, and after that, you can find the animation file in this folder, users file, user files. Let it, okay, it's 260, 270, 280, and 300. It's finished, and now you can see the animation. It's here. It's a bit fast. You can decrease the speed of the animation using another software, using your phone. But the best way is to decrease the autosave frequency. Since I had 30 frames and the frame rate was 24, so you can calculate 30 over 24, it's about 1 second. That's why I have the animation is only 1 second. So you have to increase the number of frames. You can decrease the speed of the animation using a third software, and or using your phone. That's it. There is no other option. Uh, some other software, for example, ParaView, it has the option, or TechPlot. Yes, especially TechPlot. Using ParaView and TechPlot, you have a better control over the speed of animation. So the best choice maybe is to use TechPlot and PowerView to create some animations. Okay, that's it. If you want to create animation of, for example, pressure contour, you can change the variable from velocity to pressure and do all these steps from the beginning and create the animation or any other parameter that's variable that you want. You can do it. These steps are the same. So now you know how you can do it. I think it's good, and that's it. I mentioned all the content, all the points that I wanted to say, and this should be the end of this video. Uh, I hope you enjoyed it. I hope you use it to create different and wonderful animations from your CFD results. If you like this video, please share it with your friends, give us a thumbs up button, and subscribe to the channel. And if you have any comment, you can write your comment or problem in the comment section below. And see you. You can contact me using the contact info. You can find them in the channel description. And until the next video, take care of yourselves and bye bye.